Hey guys, it's finally time to get back to the EVE 280 amp hour lithium iron phosphate battery bank installation. It's taken quite a while longer than I was hoping for this particular project to get wrapped up, but I'm on my third iteration now of how I'm going to secure these batteries, and this is finally the design I settled on. The first couple of designs had some problems I wasn't quite happy with. I was trying to go with smaller modules, that way I can take them out, move them, and service them as needed, and in the end I decided that wasn't the best approach, and I have all 32 batteries in one large block now. I ended up using 3/4 inch plywood, and I have 1/8 angle aluminum, 1/4 inch threaded rods going through, holding them at a very light compression that will hopefully extend the life of these batteries. So today's video is finally to discuss installation of the BMS. I know a lot of people were questioning what I was going to be using, when that's coming, where there's going to be more information. As you may have guessed by some comments I left in the t-shirt I'm wearing, we're going to be using a Batrium on this battery, of course, but we're going to be using something a little bit different. This is their new product. This is the Batrium Watchmon Core. This is an upgraded replacement for the Watchmon 4. So this device will work with any Longmons, MM8s, Blockmons, LiFePO4s, pretty much anything that Batrium has put out thus far for monitoring cells. And in addition to those previous cell monitoring devices, we have a new option available, and this is the Cellmate K9, and it is capable anywhere from 3 to 16S on this one device. So we're going to use this Cellmate K9 as the BMS monitor for this lithium iron phosphate battery bank, and eventually, once I have enough lithium iron phosphate, we will be completely replacing the 18650 battery packs. So in this video, we'll go through installation of the Cellmate K9. We'll talk about advantages of the Watchmon Core over the Watchmon 5 and the Watchmon 4, and of course we'll talk about some best practices that should be followed. So we've got the Watchmon 4, the Watchmon 5, and the new Watchmon Core. So this is the Watchmon 4 that I had originally started out with on my project, and this is primarily used with Longmons, Blockmons, or LiFePO4s. Next we have the Watchmon 5. The Watchmon 5 is good for, I think it's like 10 to 15S. This is what I'm currently running in service for my 18650s. This is a supervisor combined with the cell monitoring, and this device is absolutely solid. So I've been running this for several months now. It's almost been a year. And I don't have to touch it. It just works, and I don't have to touch it. The only time I have to touch it is for like firmware upgrades. So then we get to the Watchmon Core. The Watchmon Core is like the Watchmon 4, except they've addressed a number of issues that the Watchmon 4 had just to make this an overall better product. So one of the mistakes a lot of people are making with the Watchmon 4 is the shunt and the CMU connector are both 4 pins, so it's very easy to mix them up. And if you mix them up, you end up blowing up your Watchmon 4. So what they've done on the Watchmon Core is you now have a 4-pin for the shunt and a 5-pin for where your CMU connects, whether it be a K9 or the Longmon or Blockmons. So the other big difference between the Watchmon 5 and the Watchmon Core, obviously this supports 16S, and in my opinion 16S should have really been done from the start. I know there were a number of issues with chipsets and things like that. So obviously the biggest difference between the Watchmon 5 and the Watchmon Core plus K9 is that they are separated. So they have separated the supervisor or computer component from the actual cell monitoring and cell balancing. Additionally, they removed a lot of the computer logic that was in the MM8 from this K9, which makes the K9 for cell monitoring significantly cheaper. There's really no computer built into this K9. It's simply controlled by what the Watchmon Core tells it to do. So when you get your Watchmon Core and your Cellmate K9, you'll get a short cable like this, which is designed to connect the core to the K9. You'll also get a temperature sensor for the Watchmon Core. The K9 will come with a bag of 4 temperature sensors, and then they've also made the cell fuses optional, so you can go ahead and purchase a bag of these if you'd like. So these Watchmon K9s can be daisy chained the same way an MM8 can on the Watchmon 5. The Watchmon Core currently supports up to 6 of these K9s. You can add additional K9s past 6, however Batrium recommends using an external 5-volt power supply at that point. So this little cable that connects your Watchmon Core to your K9 also supplies the K9 with power. You no longer need to use an external power supply like we did with the MM8. So with all that information covered, we're ready to move on to the wiring. So with the original Watchmon 5 installation, because the supervisor was connected to the cell monitor, I ended up installing the Watchmon 5 and the MM8 in this steel enclosure. And this worked great. So what I did was I ran all the balance leads out and down, and they're very long balance leads to each battery pack. Now that the cell monitoring is separate from the supervisor or computer functionality, I think what I'm going to do is install this Watchmon Core down here. Then I will run the communications cable down to this lithium iron phosphate battery pack, and I will mount the Cellmate K9 for balancing right to the side of the battery pack like so. So then I'll have all of my balance leads come off the individual cells and go straight down into the Cellmate K9. Alright, so I secured a small piece of DIN rail here. I just stuck it in between the two pieces of angle aluminum, and I put one very short screw in, making sure that I selected a screw that would not puncture through the back of the plywood and into the battery. That is extremely important. I would definitely recommend, if you're going to do something like this, anytime you screw into a piece of wood when there's a battery on the other side, take the wood off first and put the screw in. That way there are no mistakes. Alright, it's nice and secure there. It's perfect. Now we're ready to talk about the wiring for each individual series connection for this K9. I basically made up this diagram of where each cell is, the polarities, and how they are going to connect together. I know it's a mess. My intent was not to show this, however, I think it will help in explaining this. Basically, we have a red ferrule and a black ferrule that ship with the K9. The black or 0 pin is going to go to the main negative of your battery pack. And then we'll work our way up with wires, one wire to each series connection, each place where two cells join in series, until we get all the way up here to the red terminal, or the main positive, which will go to our positive connection. Now this device supports up to 16S, and I have a 16S battery, so I will have all of these pins populated with wires. If you're doing a smaller configuration like a 7S or a 14S, you would populate pins 0 through, wherever you end, and then you would put a jumper from your ending pin up until pin number 16 to make sure the K9 has power. This differs a little bit from the MM8 and the Watchmon 5, where you had to actually jumper so many pins. So I'll be using the same 20 gauge MTW rated wiring for installation. This is the same wire I used for my Watchmon 5 and my MM8. I really like this wire. The insulation is very tough. It's difficult to damage, so it's good for an installation like this. It's very important to pick quality wiring. Some of the wiring that's out there that's cheap is very soft insulation, like your fingernail can actually cut through it and whatnot, and I just don't like that stuff at all. I'd rather pay a few extra bucks for some quality cabling. And this little pin here is called a ferrule. And the way this works is you insert your wire from the back side, and then you crimp down this metal part, and it keeps your strands bundled together. That way you're not putting stress on the strands, tearing the strands, or anything like that. It's not an absolute requirement to use ferrules when you do connections like this, but it is highly, highly recommended to do so. They're very cheap, very inexpensive. I purchased this here crimp tool on Amazon, and it came with this gigantic box of various size ferrules. It was maybe 20 bucks or 25 bucks or so it's certainly not an expensive tool, and it's a well worth investment. So I'm just going to take my wire here and strip off, I don't know, what's that, like a 3/4 of an inch or so. Then I can go ahead and insert the wire into the ferrule. And you can see some of the strands stick through. You don't want that, but that's not a problem. We'll trim those off when we're done. So now we can insert the ferrule into our tool and crimp it down. And then I just took a pair of wire snips and snipped off the extra strands there at the end. So now I can go ahead and insert this wire into my terminal block, tighten down the screw, and I will measure and cut this lead as needed. Alright, so now I've got all my leads measured and cut to the appropriate length for their series connections here. And then one thing I do want to note is that when I did the Watchmon 5 install, we had what was called a TestMon. So we plugged these connectors into our TestMon first, and that showed whether there was any fault along this wiring path before you plug it into the Watchmon 5. Now that was done because a significant difference in voltage across two pins could actually destroy your Watchmon 5. I'm told that the K9 is significantly more tolerant to voltage ranges like that. While Batrium does sell a TestMon for the new K9, it is not their requirement or their recommendation to actually use the TestMon. Alright, so now we're ready to talk about how we're going to connect these balance leads to the actual EVE cells. So the way the bus bar sits is it goes across the positive and negative terminal to form the series connection. Now what a lot of people do is simply put the ring terminal and then tighten down their nut, right? And that's an easy way to do it. So you've got your balance lead going to this ring terminal, and this nut holds down both the ring terminal and the bus bar. This is a serrated flange nut that's used on these batteries, and the teeth on the bottom of this nut bite into this bus bar, and it actually keeps the nut from loosening, and it keeps this bus bar down, torqued down to whatever spec you torque it down to. Now if I take this flange nut and I have it riding against this ring terminal here, well, now we've got a smooth surface on the bottom of this ring terminal that's rubbing against the smooth surface in this bus bar, and that's really negating what the purpose of this flange nut is, which is to bite into the material it's holding. So I'm not saying this would be a problem per se, I'm just saying that, you know, I want to try to do it a little bit better and see what I can come up with. Alright, so what I ended up doing here is I drilled a small hole right in the center of the bus bar, and then I ran an M3 size tap through it. So I now have a threaded hole for an M3 screw with a 0.5 thread pitch, which gives me approximately 3.5 to 4 threads in the thickness of this 2mm bus bar. So this is what the fuse holders look like that Batrium sells. And you want your fuses to be as close to the battery as possible, because remember, your fuses are protecting your wire. So if you put your fuses a foot or 3 feet away from the battery, you now have all that wire that is unfused that could melt and burn and catch fire if something were to happen. I'm going to start with the end that does not have the spring, and I'm going to cut it approximately 2 inches, 3 inches back from the terminal. Strip off a bit of insulation. Next, I have a rather small ring terminal here, going to insert the wire into, and just solder it down. It doesn't take much, just a little tiny bit. There we go. Alright, so now back at our batteries here, I can put down the bus bar for the series connection. So I've got an M3 screw that is 6mm in length with a 0.5 thread pitch, and I've got an M3 split lock washer, and I can thread that right into the bus bar. Another thing I also want to point out is you'll notice how short I made this lead here, and that lead is short purposely such that while I'm playing around with this, connecting these balance leads and whatnot, I want to make sure that there is zero chance of this lead coming in contact with the opposing pole and causing a short circuit. So I made sure this was cut small enough such that even if this slips back like you see here and this terminal is exposed, it will never come in contact with the bus bar or the terminal over here. There's about 2 inches of space between the end of this wire and where this terminal is. So it's very important to keep safety things like this in mind because you do not want to have any accidents. Alright, so now I'm ready to splice on the other end of the fuse holder to the wiring harness we built over here. Now for added safety, I want to make sure these pins are labeled both at the connector and at the fuse holder. So I used my Dymo label printer here with some printable heat shrinks and just printed the numbers 0 through 16. So I'm now looking for pin number 0, which starts with the black wire, or the black pin. Going to slide both of my numbered heat shrinks down. Okay. I don't really want to splice on this wire. What I really want to do is remove this wire and then solder my balance lead directly to the end of this terminal. So I find the easiest way to do this is to take a small pair of these very pointy wire snips and just snip the wire in between the insulation crimp and the wire crimp. And then usually you can just pull it straight out, like so. And we'll discard this piece of wire then. So now I'm just using my pair of pointy wire cutters to open that barrel up just a little bit where the insulation was crimped. First we're going to put on the black end piece of the fuse holder. Then goes the spring. Now we're ready to strip a small amount of insulation off the wire. Alright, so I was able to take this crimping tool here. I actually got the original terminal crimped back over the insulation. I didn't think that was actually going to work, but it did, so I'm surprised. If it doesn't work, you can just squeeze at the pair of long nose or whatnot, but obviously the wire is still not crimped on itself, so we need to solder that to the connector. Alright, so you can see how that's soldered on there. I would suggest maybe using a little bit less heat than I used. Alright, so now I've got a nicely connected fuse holder, labeled pin 0, and it's also labeled pin 0 on the connector side, so now I just have 16 more of these to solder and label. And there's the completed wiring harness. All of the fuse holders are now attached and labeled. Just apparently I got the heat gun a little bit too close to the end of the terminal blocks here, but it's all good. Alright, so now I've got my wiring harness plugged into my K9. All my leads are coming down here. I got my pile of bus bars with fuse holders on them. I got my wiring diagram ready to go. So I am ready to begin installation of the series connections. Alright, so now I'm just taking one of these bus bars with fuse holders and I am dropping them every place where my diagram says there should be a series connection, being very, very careful and making sure, absolute certain, that I do not short out these cells because that would be very, very bad. So And that's one of the reasons why I made a diagram, and I've voltmetered these out many times just to make sure the polarities are all correct and everything like that. Alright, so I've got all of these series connections completed. I've got a fuse holder on each one of the series connections. And you can see here what I was talking about why it's so important to make sure your fuse wires are short enough such that it won't short out. So as you can see, they're all short enough and there's no chance of these wires coming into contact with the opposing bus bar. So while the K9 is more resilient to accidents than the Watchmon 5 and MM8, I'm still going to unplug these plugs for safety as I connect my fuses, because it's not completely immune to, accidents and mistakes. So I'm going to take the wire labeled pin 16, and I'm going to verify the fuse end also says 16, and I can insert my fuse into the fuse holder and tighten it down. Now I had planned to run all my cabling right down the center path here. However, I neglected to take into account that there are bus bars here, and I do not want this wire to cross over this bus bar. So I'll have one bundle here, a bundle here, and then a third bundle over here. Alright, so all of my fuses are installed here, and I will work on wire management once I verify they are connected correctly. So I've got my voltmeter here. The negative lead is going to the main negative of the battery. So if I look at the main positive here, I've got 54.6 volts, which is full battery voltage. So I'm now going to start the lowest connector, and if I put my multimeter on pin 0, I should see 0 volts. And then I'll keep going up one by one, and I should see the voltage increase by approximately 3.3 or 3.4 volts each. So I've got 3.4, 6.8, 10.27, so I'm at 51 and 54. So I've now verified that all of these wires are in the correct order. So I've got the TestMon here. Again, this is optional, but I'm going to give it a try anyway. So you always plug in your low connector first, which is pins 0 through 7. And then plug in the high connector, which is pins 8 through 16. Alright, 16S. I'm going to push it once, and it says pass. So I now know my wiring is complete and is wired correctly. Verified using the TestMon. If it were wired incorrectly, it would say fail, and then you'd be able to correct it. So I'm now ready to transfer my connectors to the K9. Unplug the high connector first, and then the low connector. It's always that order. It's very important. Alright, so now I can plug in my low connector first, again, pins 0 through 7, and my high connector, pins 8 through 16. Okay. Alright, so that did not come out near as nice as I, imagined it would have, but at the end of the day, it's about whether or not it's safe. It's not about how it looks. Alright, so now we got 4 of these temperature sensors we need to get connected. So it's just a small white, that's a JST connector I think on the end. And those just get plugged into the white connector on the K9. Alright, so I've got 3 of the 4 temperature sensors affixed to bus bars like you see here. And I just used a bit of hot glue to hold them into place. I think a mechanical connection would have been much better for the thermal properties, but I didn't want to be drilling more holes than necessary in these bus bars. I already drilled 1 hole in each bus bar for the balance lead. And then the 4th sensor I just stuck under the black label for the cell. That way I have at least one up against an actual cell body. And I've got all that extra slack wire rolled up at the K9, and they're all plugged in. Alright, so now I'm ready to put my Batrium on the DIN rail, my Watchmon core here, and plug in the ambient temperature sensor. Alright, so next I'm ready to connect the CMU or the K9 to the Watchmon core. And that's done using the 5-pin connector with a blue dot. Now, unfortunately, this cable that Batrium provides is obviously too short to connect the Watchmon core and run all the way down to where the K9 is down there. So I've taken this cable that comes with the ISOMON. It's the same cable as this short one here, it's just longer. And I've made sure that the pinout matches. So on the original one you can see both connectors from left to right are red, green, yellow, black. And on the longer cable we have red, green, yellow, black. So we are good to go. Now I have made the recommendation to Batrium that they consider selling these cables, as an accessory item in their store. Because as simple as it sounds, it's actually difficult to find good quality, twisted pair cable. I wanted something that was shielded to twisted pairs. I didn't want to use Ethernet cable, but Ethernet cable is all I could find. You can certainly use Ethernet cable just to make sure that the pins are in the correct order And you should have yellow and green should be one twisted pair, and red and black should be a second twisted pair. Alright, so on the K9 side, this will go into the plug labeled CMU in. And you'll notice the one labeled CMU out has this little jumper pin. This jumper pin jumps the RX to the TX, and is important that this be installed on the end of the chain of K9s. In my case, I only have one K9, so that jumper pin is installed in the CMU out. And again, on the Watchmon core side, the CMU connector goes to the blue dot 5-pin plug, labeled high-speed CMU. Okay. Now this is where my setup's going to differ a little bit, because I cannot decommission this Watchmon 5 yet until I have my lithium iron phosphate ready. So rather than plugging in pack voltage for my input, I'm just connecting to a tap off my 12-volt Meanwell isolated DC power supply for the time being. And then once I'm able to move away from the 18650s, I'll reconfigure the power input for this. Alright, so next we're ready to install the Batrium software and load firmware. So you'll have a downloaded MSI file, a Watchmon Toolkit installer. Once that's complete, launch Toolkit and finish. And I've already got a Batrium connected here, so I need to switch the connection method to USB. Alright, so now we can go to Menu, Tools, Firmware Updater, and target image is a Watchmon core. We'll verify the toolkit's not running, and select your COM port here. I've only got one, it's plugged into COM11, and click Upgrade. So it's going to go ahead and launch the firmware updater and do some things. Alright, so it says Success, Upgrade Completed. Now we can go ahead and click Toolkit to reopen the toolkit. So you can see we've got Connect, Software, and Firmware done. We need to run the Wizard Setup yet. Click the Wizard Setup. If you agree and understand, you can click the Understand button. Alright, so now we have battery type is lithium iron phosphate. I'm going to pick Long Life. The Cellmate type is a Cellmate K9. Total devices is 16. So I have a 16S battery, so I'm going to enter 16. If your battery is something less, like a 7S or a 14S, you would enter that here. And I'm going to set my shunt to none because I do not have the shunt plugged in yet. And these are 280 amp hour cells. I have two in parallel, which gives us 560 amp hour capacity. Go ahead and click Save. And your pin code. If you don't know your pin code, it's on the bottom of your BMS. And click Enter. Let's try that again. Alright, so now it's sending settings to Watchmon, and you can see it going through each of the steps. We can see all of the steps were successful here, and there are no errors. So we can go ahead and click Menu and go back to Chart. And I'm going to unplug and replug the power of the device to restart it. Alright, so now we've got cell voltages. So we can see the min is 3.32, the max is 3.45. It looks like two of these are quite a bit lower than the other ones. However, these have been sitting for a number of months, so perhaps I just need to charge them up. Alright, so one thing we did skip in the setup checklist here was the device sync, because the icon was already green. You may not need to run it if you have 16S, you will need to run it if you have less than 16 cells in series. However, regardless, it is Batrium's recommendation that you run the device sync anyway. So I'm going to go ahead and click that icon. It's going to pop me to the Cellmon tab in the device synchronization page. So I just need to click Start, and it says Sync running, and it will take a little while. It does say device out of sync. However, I think it is still finishing up here. It looks like it's in sync now because the icon went away. Oh, the icon's still there. Alright, so now I see it completed because the device sync icon has disappeared. However, this dialog is not indicating that for some reason. So I will provide that to Batrium for feedback. So if I go back to Chart and then open my checklist again, I can see the device sync is completed. Alright, so one last thing I do need to do here is get the Wi-Fi connected so I can disconnect the USB. So I'm going to hit Menu and go to Tools. We have Join Wi-Fi AP on the top right. So it's going to go ahead and scan. When your access point comes up, you can click on it. It will populate the SSID, enter your password, and click OK. It's always tricky getting these Wi-Fis connected for some reason here. Oh, it looked like it almost connected. I don't know. Oh, there we go. Wi-Fi link made, and now I have an IP address. So I can click Close, go back to my chart, and down on the bottom left here I can click the USB icon. I should be able to switch this to Wi-Fi. Here is my new Watchmon core. It's listed as hardware version 14.5. Alright, so there we go. The BMS is finally installed on my EVE 280 amp hour battery pack. Like I said, it did take quite a bit longer than I wanted to get this project wrapped up. However, I'm glad that it's finally to a point where I can use it. If you're interested in checking out the Watchmon Core or the K9 and see what they can do, I'll leave a link in the description of this video. Batrium has generously provided us with a code for free shipping, and that code is BATTERY in all capital letters. I'm not sure what exactly that's going to work on, however, I know it will work on at least the Watchmon Core with the K9 kit. That is not an affiliate link. I do not make any sort of commissions on sales of Batrium or anything like that. That is simply for you guys and your purchases. I actually had to pay for shipping for my Watchmon Core. And also, just to keep full transparency in mind, I did work directly with Batrium on this video for two reasons, really, because I'm trying to make sure I get all the technical details right of the installation to make sure there are no mistakes. And second of all, I'm working with this product at a beta capacity at this point, so I'm providing feedback to them in terms of documentation, functionality, and whatnot. In upcoming videos, we'll be taking more looks at the Watchmon Core. We'll be connecting things like the ABB circuit breaker. We'll do some fans. We'll put some fans on the K9. We'll be installing a second K9. I'll be doing some capacity tests of this battery bank as a whole. So definitely keep a lookout for those videos. Until then, hit that like button before you go, and thanks for watching.